Hello, hi everyone. In the last class, we have seen the overview of CAD CAM. We have also seen the benefits of CAD, and finally, we are discussed the information flow in CAD and CAM, from which place the data is originating and from which place the cycle is ending. The starting point and ending point of the CAD and CAM we have seen in the last class, the last session. I'm glad to see in this session, I would like to explain the hardware devices used in CAD side. The objective of this slideshow is to discuss the following contents. The first content is CAD Workstation. We will see the different hardware components in CAD system. Then we will move forward to see the input devices. We will also see the graphic terminal, which is in turn we are calling as a cathode ray tube. We will discuss how the CRT is going to work in detail. Then we will see the hard copy devices used in CAD Workstation to get the output in the form of documents. We will also see those devices. Finally, we will also discuss the storage devices used in CAD side, because CAD involves the CAD file consists the huge amount of data when you create a model, so that we will see the devices used to store this huge amount of data. So what exactly the CAD workstation is that it is an interface, how this interface is going to interact with the uh, outside world. So we can call workstation is nothing but a system which is going to interact with the outside world. We can say that the workstation is a system used to interact with the user. Instead of calling it as an outside world, we can call it as a user. The objective of the CAD workstation is it must be able to interface. It must have the central processing unit. I mean, the workstation must interact with the central processing unit. Central processing unit is a device used to process all the data, just like a unit in a computer or a computing machine. It must be able to generate a steady graphic image for the user. The CAD workstation must be able to generate a graphic image for the user to understand, to visualize the image. It also should be able to provide the descriptions, digital descriptions of the graphic image. Digital descriptions means the user, the moment the user creates a CAD model or an object or a component in the device, in a display device, it must have some properties like it must be able to convert from one form to another form, just like the properties. It should be able to display the properties. It should be able to describe the properties, image properties like JPEG format, JP or bitmap format, or it should be able to display the pixel size of the image. So the CAD workstation must also able to describe the image properties. It must have that feature also. Then the CAD workstation should also translate the computer commands into the operating functions. So it must be able to transform the computer commands. We are executing some commands using some software. Example, you take a CAD software. So whenever you want to draw a line, so you must use a line command. So when you type a line command in the CAD software, So it prompts us. The system software will prompt us to select the start point, and the moment you select the start point, the system will ask for the next point or the end point. So in between start point and end point, so the system is going to draw a line. So when you use a draw command, the system is going to draw a line. So that means the workstation is transforming the commands into the operating functions, means it is drawing the line, or it is converting the commands into the functions or the operating functions. The CAD workstation must have that feature, that consists that feature. Then it must be able to communicate between the user and the system. This feature is very, very important. It must be able to communicate between the user and the system effectively. These are all the workstation must have. The function must be able to fulfill all these functions. Then we will see the, I mean, CAD hardware. The, I mean, workstation mean basically is consists the different hardware devices. Uh, the most of the hardware devices are listed in this slideshow. So one is the storage device. It must have the input device. Then it must have the graphic terminals to display the output. It also must have the output devices. Along with these four devices, the CAD workstation is also having the central processing unit, like a computer. So when you move forward, we will see the hardware components used in CAD system. This is exactly the typical hardware components, typical diagram which shows the configuration of hardware used in CAD system. As I said just now, it must have a central processing unit to process the data, to execute the commands, in which you have the processing or the all the hardware. This processing unit consists all the hardware to transform the commands into executable functions. It will issue the signals. It will send the signals to execute. As I listed in the previous slide, this hardware components in CAD system consist the storage devices. The examples of these storage devices are hardware, hard drive, maybe it is hard disk drive or storage disk drive, SD card, maybe it is a flash thumb drive or USB thumb drive. It may be a CD or DVD drive, etc. And these are all the devices used to store the information, information in the form of in the soft copy form. Then this CPU is going to interact with the storage devices. Suppose if you want to use a flash drive, flash USB drive, it must have the USB port. So we are going to insert the USB port where you have some slot. So if you insert a USB port, USB in the USB port, so you have an access to, you have a provision to access the data stored in the USB drive. So you can store, you can retrieve the data, you can transfer the data from system, from CPU to the storage device, and you can also copy the data from the storage device into the system. So in both the ways, it have control. You can store the data, you can copy the data into the storage device, you can copy the data from the storage device to the system or the central processing unit. Then this central processing unit is also connected to the output device. Just like you assume that you are plotted a drawing, you are created a solid model. If you want to create, or if you want to take the, if you want to store that in the form of document or in the form of hard copy, in that case, so you need to get the print. So this CPU is also connected to the output devices. The examples for the output devices are the plotters, printers, even you have the different types of printers, plotters, right? Pen plotters, drum plotters, right? flatbed, as well as you have drum plotters. So these are all the output devices. So these are used to get the hard copy of the drawings or the data. Then the CPU is also connected to the workstation, design workstation, where exactly we will we will see the output. So this design workstation consists the graphic terminal. In turn, it can also be called as a cathode ray tube, CRT. Then you have the input devices. Basically, when you take an example, computer, you take an example of a computer, the data fed into the computer using a keyboard or maybe using a mouse. You have other devices like the light, pen, scanner, and all these are also used to input the data into the system. This is also two-way type. So it takes the data and it also gives the data to the CPU. So graphic terminal is a device, output device, which you can see on the screen. Assume that you are created a 3D model. That 3D model can be visualized on the screen. This graphic terminal is used to display the components and also to simulate in the case of manufacturing. So before starting the manufacturing, the manufacturing will be simulated using some softwares. This is the typical configuration of hardware components used in CAD system. Once again, I will try to list out the devices used in the CAD system is storage devices, then CPU, you have the output devices, then CPU is connected to the input and output devices. Similarly, CPU is also connected to the graphic workstation. The elements in this graphic workstation or the design workstation is the graphical terminal and also input devices. For example, keyboard, mouse, light pen, scanner, etc. Joystick is also one of the input device to control the cursor on the screen. So all these two, graphic terminal as well as the input devices, are called as the design workstation. Most of the times the user is going to interact, maximum time the user is going to interact with the design workstation. So that's why, so this is called a workstation. Then when we move forward, we will try to explain everything in detail in the coming slides. These are the input devices. So devices through which the user communicates with the system, communicates with the computer or the CPU for feeding the necessary information is called the input device. The device used to interact or communicate with the computer is called the input devices. Basically, these input devices must have some qualities. So those qualities, the first quality, it must have the resolution, proper resolution. It must be able to key parameters. Here we are calling these parameters as the key parameters. So it must have the resolution. The resolution is nothing but the smallest distance the device requires to recognize the two adjacent points as spatially separate or disaddressable, DPI. Then it must have accuracy. The error in the measurement of the actual data by the input data called the accuracy. Then it must have the repeatability. So repeatability is nothing but measuring the device's ability to return to the initial position, or it must be able to come to the return position, is called the repeatability. Then it must have the linearity. So linearity is nothing but measuring the responses of a device to the user hand movements. So these are all the input devices used in the CAD CAM workstation. I mean, these are not the input devices. These are the qualities of the input devices, or the key parameters of the input devices used in the CAD system. It must have the proper resolution. It must have the proper accuracy. It must have the repeatability quality. It must have the linearity. These qualities are essential when we use a device as an input device. Then these are all the input devices used in CAD system, CAD system. So obvious keyboard is one device, mouse is also one device. So almost everybody is aware that the keyboard, mouse, light pen is also used to input the data to the CAD system, joystick, digitizer, and scanner. So let us discuss all these devices, input devices in detail in the coming slides. So as I said just now, mouse and keyboard are the familiar, are the most basic input medium for all the computers, mouse and keyboard. If you purchase a computer, every computer is incorporated or attached with the keyboard as well as the mouse. Keyboard is a basic input medium for all the computers and mouse also. Okay, keyboard is just like a type machine. Keys are provided on the flat bed, typewriter like machine. Okay, on which you have the alphabets, numbers. Then we have the special keys with the special symbols. Then you have the arrow keys to control the cursor on the screen. Then you have the other keys to control the cursor on the screen. Then you have the mouse. It is basically a pointing device. So whenever you want to operate some commands, so in that case also mouse is used to control the cursor on the screen. The mouses are basically two types. One is optical mouse, then you have the mechanical mouse. In the case of mechanical mouse, we have a spherical ball. The mechanical mouse consists of a spherical ball. Whenever we move a mouse, the spherical ball, the rotary motion of the ball is converted into the linear motion by pressing this spherical ball against the rollers. Whenever we move this mouse horizontally or vertically, those movements are captured, and those movements, those coordinates, means x coordinate as well as the y coordinate, are connected to the mouse pointer. When we move a mouse, so based on the movements of the spherical ball movement, in turn the horizontal movements means x coordinate, the vertical movement is going to control by the by one cylinder. So those x coordinate and y coordinate is transformed to the screen. So in that way, this mechanical device is used. Then we have an optical mouse. In the case of optical mouse, a, a laser beam is projected on a grid space on a pad, which is divided into the cells or the grids. When we move a mouse, optical mouse, on the space provided on the pad, the movements of the mouse is transformed as the x and y coordinates by using the beam, electron beam, or the uh, ray light. These are the two types of the mouse frequently used in optical mouse and the mechanical mouse. Input devices. When we come to the next type of input device is light pen. Light pen is a pointing device in which the computer seeks to identify the position where the light pen is in contact with the screen. That means we can see the light pen in this figure. We have a screen on which whenever we move a light pen in contact with the screen, this light pen is going to move on the screen horizontally and as well as the vertically. Right? The movement of the light pen, the movement of the light pen, basically this light pen is energized electrically. I mean, electrically charged. This electrostatically charged pen, when we move on the screen, phosphor bronze screen, phosphor coated screen, the electrons on the particles on the screen will be energized to get the image or to get the cursor or to control the movement of the cursor on the screen. whenever we move this light pen, electrostatically charged light pen on the screen, the particles on the screen will be energized. In turn, we will get the line or the image on the screen. This is basically the working principle of the light pen. Then you have a joystick. Joystick is also one of the input device used in CAD station to control the movement of the cursor on the screen. You can see a joystick on the screen. It must have one lever type device. Lever, one end of this lever can be operated by hand. The other end is placed in a spherical hole. So whenever we move this lever horizontally or vertically, or forward movement or backward movement, the movement of this lever will capture the movement of the cursor on the screen. This joystick is basically used in the case of video games, frequently used in the case of video games. Now this is obsoleted now. This is not used along with the computer. This joystick is used in the case of video games basically. Joystick is also used to control the cursor of the movement on the screen. It is also just like a mouse. Light pen and joystick is also, these two are also input devices used in the CAD system. Then the digitizer and the scanner is also two input devices used in the CAD system. Digitizer is also known as a tablet used in low resolution digitizer. Tablet is also a low resolution digitizer used for converting the physical locations into the coordinate values. Scanner is also a device. You can see a digitizer figure here. Digitizer is also nothing but a tablet with a low resolution screen. This is also used for converting the physical locations into the coordinate values, namely x coordinate and y coordinates. You can see an example of the working of the digitizer in this screen. Digitizer consists one's screen on which this digitizer is also connected to one terminal where a device is used to read the coordinates on the physical form. That means you have, whenever you want to read the coordinates of a physical object, that may be a drawing sheet. So we want to measure the coordinates on the drawing sheets, the coordinates of the figure on the drawing sheet. In that case, we connect the digitizer terminal to one of the device connected, one of the device which is moving on the physical object like a drawing sheet. When we move that device on the drawing sheet or the physical object, those coordinates are plotted on the digitizer. In turn, the digitizer is converting the physical coordinates into the into the physical values or the physical locations into the readable coordinates onto the screen. The basic principle, working principle of the digitizer is to convert the physical locations into the coordinate values into the system. Scanner is also a one device used for producing an exact digital image replica of a photo or a text written on the paper or even an object. You might have seen a scanner on the outside, right? You can see the scanner figure. Not generally used scanner is a flat bedded scanner on which we will place a paper here, and which you can place an object or a paper here. In this case, a paper is placed on this. Here, the electronic beam is going to move on the electron beam is going to move on the surface of the paper. The electron beam is going to read the data on the data, capture the image. That image is sent. That image is sent to the computer or reads the data on the screen. Then that data will be sent to the screen to capture the data in the form of JPG or bitmap. Scanner is a device basically used for producing or reading the text on the paper, or reading the text on the paper is just like OCR, optical character reader. Then it can also read the photo. It can also be used even capture the data of an object or image of an object. So normally used, the scanner is a flatbed scanner. So these are all the input devices used in CAD system. A keyboard, mouse, light pen, joystick, digitizer, scanner, all these are, out of all these, scanner is used, digitizer is used frequently. Mouse and keyboard is obvious. Whenever you purchase a computer, mouse and keyboard is connected to that. But most of the times, means 90% data is fed into the CPU using keyboard and mouse. The other devices like the light pen, joystick, digitizer, and scanner is very rarely used to read the data or to input the data or fed the data into the computer. The other one is the graphic terminal or cathode ray tube. So this comes into the workstation. Most commonly, this is a most common display medium used in CAD Workstation. The most common used display device used in CAD Workstation is CRT, cathode ray tube. In this case, a heated element is going to emit, so that in turn we can call it as a cathode, is going to emit an electron beam, and that electron beam is going to be projected on the PASPER coating. This electron beam movement is controlled by the deflectors. You have horizontal deflector, you have vertical deflector. The moment of the beam is controlled, the horizontal moment of the beam is controlled using the horizontal deflection plate. The vertical moment of the beam is controlled by the vertical deflection plates. Whenever this PASPER bond, whenever this electron beam impacts or focuses on the PASPER coating on the screen, this electron beam is going to energizes the particles of the PASPER coating. This energizes, this emits, this energizes the PASPER coating particles on the screen, in turn, which will display the image on the screen. The whenever we want to display whenever we want to display the image, this electron beam intensity is varied to display the image, because image is having different intensity of the particles. The image is displayed in the form of different intensities of the particles. This electron beam is going to energize the particles in the different intensities to get the or to capture the image. The movement of this beam, as I said just now, is controlled by horizontal and vertical deflectors to get the or to display the image on the screen, to display the image on the screen. There are two different techniques to create image on the CRT screen. One is stroke writing, the other one is raster scan. In the case of stroke writing, the image is constructed out of a sequence of a straight line segments. The stroke writing is shown in this figure. When we specify x and y coordinate, means it is a start point. When we specify the next point, it is just like drawing a line with a pencil, right? When we specify the next point, it is going to connect the previous point and the next point, just like drawing a line on the line with the pencil. We are going to write something on the screen in this manner. Then you may get a doubt that then how do you write or how do you draw an arc or a circle or a curved object on the screen? In that case, the line segment is the line segment is drawn on the screen by directing the beam to move from one point on the screen to the next. Okay, this is one way of writing the screen, but the doubt is that how do you draw a curve, an arc on this screen? That is our doubt. That can be approximated. These lines, these horizontal and vertical lines, or these straight lines, are approximated as a short lines. When we reduce the size of this horizontal or a straight line, when we reduce the size of the lines or the straight lines, we can approximate these lines as a very short lines to create the arc or circular lines on the screen. To draw the circular or curved lines on the screen, we are going to approximate these lines as a short length lines to draw the circular or arc lines, curved lines on the screen. Stroke writing is one of the concepts, just like drawing a line with a pencil from one point to the another point. This is one concept. Then you have a raster scan. In this case, the viewing screen is divided into a large number of discrete pass per picture elements. That means the screen is divided into grids, small size grids. Picture elements called the pixels. We can also call those as pixels. The total screen is divided. The total screen is divided. The total screen is divided into large number of discrete pass per picture elements called pixels. The matrix of the pixel consists the raster. That means raster means moving the cursor line by line. The moment the raster or the electron beam moves from left to right, after coming to the end point, again it will start from the start point. So line by line, it is going to energize the particles, pass per particles on the screen to get the picture, to get the line or to get the curved lines on the screen. Whenever we want to get the image, this electron beam or the pixels intensity will be varied. In this way, raster scan and stroke writing, these two approaches are used to create the image on the screen. Then you have the hard copy devices. These are also very, very important. So the moment your design is complete, in that case, if you want to store that design in the form of a document, in that case, you require some output devices. The output devices used in CAD system, you might have seen the laser printer outside, which gives us different prints. You might have seen the dot matrix printer. Of course, this is obsoleted now. Then you have the inkjet printer. Dot matrix printer and inkjet printers are outdated and obsoleted now. These are not used frequently. Then you have the laser printer. Laser printer is frequently or mostly used in almost all the offices to get the print. Of course, dot matrix and inkjet printers are used in offices, but very rarely. Dot matrix printer consists the different vertical banks of needles. There are different needles which are located in the vertical plane. I mean, the bank of the needles are located in the vertical plane on which a tape is going to move. So that tape consists of ink on which a paper is going to move. Whenever you want to get an image, or whenever you want to get the text, or whenever you want to get something on the paper, these needles in the vertical plane is going to impact on the paper located on the needles to get the print on the paper. A carbon paper or the ink paper is located between the paper as well as the ribbon. Of course, you can call it as a ribbon. On the ribbon surface, on the ribbon side, the vertical needles are going to be projected, are going to give impact on the ribbon in turn to get the print on the paper. These needles also moves on the horizontal plane to get the print. These needles are also connected to the head or a carriage, you can call. This carriage can move horizontally and the vertically. Vertical movement, of course, the vertical movement will give us only with the needles. The horizontal movement will be the carriage which carries the needles. Then you have the inkjet printer. The principle of the dot matrix printer and inkjet printer is same, except the ribbon. In the place of ribbon, these needles are going to shoot the ink on the paper to get the image or to get the print on the paper. So directly these needles are going to spray the ink on the paper to get the image. Then you have a laser printer. Laser printer is having a semiconductor laser a drum. So this drum is energized electrostatically, energized or charged electrostatically. The moment this drum electrostatically charge, the moment when you charge the drum electrostatically, the toner powder sticks to the drum on which a paper is going to roll to get the print on that paper. That means this laser printer consists a drum. That drum is electrostatically charged. This electrostatically charged drum is moved in the toner, which consists the ink. This drum, whenever this drum moves in the toner, toner consists the ink powder. That ink powder sticks to the electrostatically charged drum on which we are going to roll a paper to get the charged particles onto the paper. This is what exactly the principle of the laser printer. Dot matrix printer, inkjet printer, laser printer, these are extremely used to get the output in the form of hard copy. Laser is frequently used. Dot matrix and inkjet printers are rarely used. These are very cheap. The cost of the print is very cheap with the dot matrix and inkjet printer. Laser is bit cost than inkjet and dot matrix. When you come to the plotters, so we have different plotters, pen plotter, even pen plotter is having two types, flat bladed plotters and drum plotters. In flat bedded plotters, we have a flat bed on which on which on which a pen is going to move. In this case, in the case of pen plotters, a ink pen is used to plot the drawings or the images on the sheet or wherever you want. This pen is connected to the terminal, which receives the signal from the system. According to the signal, this pen is going to plot the image on the flat bed. Then you have the drum platter on which a paper is rolled on the drum. This drum is going to connect it to the rollers. It is free to rotate on the bearings. Then you have a plotter. This plotter is going to plot the image on the drum on which a paper is rolled. Then you have the electrographic devices. So normally have a smaller built-in screen inside the recorder. These are not much important with respect to our uh, uh, CAD drawing is considered. Of course, these are used, but very rarely used, very rarely connected to the, very rarely used in CAD system. Then you have the storage devices. These are also very, very important in CAD system. The moment you complete the drawing, the moment you complete the program, the moment you create a 3D drawing, so you need to store that in another device, or whenever you want to transfer the image or a drawing or a program from one system to another system, you require the storage devices. There are different storage devices used in CAD system. One is magnetic disk. So in turn, we are calling those disks as CD drive, then DVD drive, Blu-ray disc, etc. Then you have the hard disk drive, HDD, hard disk drive. Then you have solid state drive, SSD, and USB flash memory, USB drive. So these are frequently used in CAD, computer aided design system. When you come to the magnetic disk drive, you might have seen CD, that image you can see on this screen. It is on which you have a coating, optical coating. The data is stored in this disk in the form of the binary data. This disk is going to store the data in the binary form. Binary form means zeros and ones, on which you have some coating. This disk is having some concentric circles on which the data is stored. The texture on this disk, the texture on this disk is going to store the data. Texture, maybe its intensity, its resolution, maybe the texture is this texture. The properties of the texture is going to read by projecting the electron beam on the surface of this disk. The moment you project the electron beam on the surface of this disk, the electron beam is going to read the texture, maybe its depression, its projection, what extent it is having depressed, and what extent it is having projection. In turn, you can call it as a bumps also, bumps and impressions. So this uh, beam is going to read that bumps and ups based on the texture. The electron beam is going to read the binary data on the magnetic disk drive. It can store less amount of data when you compare with the other disk drives. Magnetic disk drives you might have seen outside, DVD drives, CD drives. It can store maximum 2 GB, 3 GB data, not more than that. Then you have the hard disk drive, HDD. This hard disk drive is used in the computer CPU. Every computer CPU consists the hard drive. The specification of the computer is also based on the memory of the hard disk drive. How much amount of data this HDD is going to store. The HDD consists a magnetic storage devices capable of remembering the vast amount of data. This is a non-volatile magnetic storage device capable of remembering vast amount of data. 1 TB, 2 TB hard disks are available in the market. Even 5 GB, 10 GB, 10 TB is also available in the market. You can purchase. In the case of HDD, a magnetic disk is going to rotate to store as well as to read the data on the disk. This is also very, very important drive used in the CAD workstation. The size of the hard disk drive is more some extent when you compare with the other devices like solid state drive, SDD. Solid state drives are also non-volatile storage devices capable of holding large amount of data when you compare with the HDD. HDD is having some moving device. You have some magnetic disk which is continuously rotating to read the data as well as to store the data on the disk. Whereas solid state device HDD is not having any moving element, any moving device. The HDD and SDD solid state drive is going to use the NAND gates. Means microprocessors are connected. Millions of microprocessors are connected in series to store the data on the circuit board. When you compare the capacity of the SDD, the HDD capacity is more. It can store more amount of data than the HDD. The HDD is having one rotating device. SDD is not having any rotating device, so that the life of the SDD is more than HDD. When you compare with the data, SDD is going to store more amount of the data than HDD. Both uses NAND flash memories and gates, means millions of transistors are connected together in series on the circuit board to store the data. Then you have the other memory device used in CAD workstation is USB memory. USB, you might have seen outside USB memory. Every computer, every CPU is having one slot USB port in which this USB drive is inserted to get the data and as well as to copy the data. You can receive the data and as well as you can input the data into the CPU. This USB drive also uses NAND flash memories to store the data. It also uses millions of transistors. or which are connected in series wise on the circuit board to store the data. Magnetic disk drive, hard disk drive, solid state drive, USB flash drive. So these are frequently used in CAD workstation. These are the storage devices used in CAD workstation. In the next class, we will try to discuss modeling techniques, 2D modeling or solid modeling techniques. Basically, we will try to discuss the modeling techniques, 2D modeling techniques, 3D modeling techniques, types of CAD softwares we will see, which are commercially available in the market. Then we will see the features of the CAD softwares. Finally, we will discuss the computer communication networks in the next class. Thank you for this session. Thank you, one and all. Thank you.